I just ran Flask application inside Docker and my Postgres database is running too. Let's look at the browser. If I look at the browser, I see an error saying connection to server at localhost failed. This is one of the most common mistakes engineers make when running multiple container applications. In this episode, we will break it, debug it, and fix it step by step. Before we dive in, if you want to master DevOps through real world simulations like this, hit subscribe right now. On this channel, we don't do theory, we do real world debugging. You don't want to miss the next episode. Here's the root cause. Let me draw two quick boxes. One is Flask container and the second one is database, Postgres database container. And from this container to this container, it is trying to connect using localhost. Means inside Docker, each container has its own localhost. So when Flask connects to localhost, it is trying to point to itself, not Postgres database. That's why it fails. In my DevOps full course video, I showed you the difference between NAT network versus bridge network. NAT keeps the VM isolated. It's like Docker's default network. Whereas bridge network lets the VM share the host network, just like Docker's user defined bridge network. If you haven't watched my full DevOps course, I explained NAT versus bridge networking in detail there. That's the perfect foundation before Docker and Kubernetes. Check it out after this video. Now let's jump into the demo. First, I'm going to run the database. Here I'm running Postgres in Docker, setting up username, password, and database. This is a real Postgres database isolated in its own container. Press enter. The database is running. So let's look at the application code. In this episode 3 folder, I have application.py, Docker file, requirements.txt, environment file. First, I'm going to start with application. This Flask application connects to a Postgres database, but here's the problem. Host is equal to localhost. On my laptop, that works fine. Inside Docker, localhost means the container itself, not the database. So this one line guarantees our application will fail. Now look at the Docker file. It's the same exact Docker file we are trying to use from Python. Working directory is application, copy requirement.txt, then run pip install no cache directory -r requirements.txt, followed by copy, then expose, then we are trying to run the application. It's the same exact steps which we did in our previous episode. In requirements.txt, we are adding another dependency that we are trying to install, and I have .env file. In production environments, we are not going to hard code on our terminal. Locally, you can do it on your machine as I did here. But in production environments, this is not the right way, the command line. We need to use .env files, pass values there. I'll show you. I'll try to show you how we are going to run this now. Also, we need to add .docker-ignore. If you see, I tried to add .env file as well. My credentials are not getting copied to the image itself. So now we are going to build Flask application. I'm going to use version 5 space dot, press enter. So it will try to build the application. Then we are going to run that real quick. So for that, I'm going to say docker run. They are all these commands are like the same commands which I used in my previous video. So I'm not explaining once again. Docker run -d name Flask. I'm just changing the version here, and also Flask application -v5 would be the name. Press enter. Now our both containers are running. Now let's try to list the containers. So I can see Flask application v5 is running, and also our Postgres is running. The containers started successfully. If I jump to the browser and refresh, I see connection to server at localhost port 5432 failure. Flask is trying to connect to Postgres at localhost port 5432 and it fails. That's because localhost here points back to the Flask container. As I showed you, if you look here, we are trying to point it back to our local host. That's because localhost here only points back to the Flask container. The database is in a completely separate container. Now let's try to stop that real quick. Docker stop the container name. The same for Docker stop container name. And then we are going to remove this as well. Flask -app -v5 docker rmi docker rm followed by I am going to remove docker rm flask db. Press enter. Now let's try to create a network. For that I am going to run docker network create flask -net. Press enter. Docker network ls will give you a Flask network. Okay, it's a bridge network as you can see. Now I'm going to update this localhost with flask -db and save. Then we are going to rebuild the application. Docker build command followed by version 6 would be, let's say, the latest version. We have successfully built our Docker image. Now let's try to run the database once again. For that I am going to use flask -db as the name followed by the network which we created, flasknet, and environment file. If you see from my previous step, I did not hardcode my username password. I am trying to pass this .env file so that my username and password are safe. Postgres database. Press enter. The container started. Followed by the next container, that is our Flask application itself. I'm going to use docker run the same. The only flag we are adding here is flask -network. Let me change the version real quick. That is 6. Then 6 here as well. Press enter. Now let me clear the screen. Docker ps. Our both containers are running. Let me go back to my browser and try to refresh. And here we are. Hello from Flask plus Postgres. What did we do? We created a user-defined network and connected both containers to that particular network. Now, instead of localhost, Flask connects to the Flask database. Docker's internal DNS resolve container names. Let's do a quick recap of what we learned today. Flask and Postgres were running in separate containers. Each container had its own local host, so Flask couldn't see Postgres. The fix was creating a Docker network and using the container name FlashDB instead of localhost. In this episode, we broke Flask plus Postgres networking, saw why localhost fails, and fixed it with Docker networks. In the next episode, we are going to simplify everything with Docker Compose, manage multiple containers with just one file. And yes, we are going to break that too. So you learn how to debug Compose like a pro. If this helped you, hit like, subscribe, and drop a comment. What's the trickiest networking issue you faced in the Docker? Thank you for watching and see you in the next video.